Okay, hopefully you got that before me. Well done if you did. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Assalamu alaikum wa rahmatullah. Peace be with you and the blessings of God. A-level Maths live lesson on proof. Continuing what we've done before and looking at proof, and today's a little bit harder, just a touch harder, because you have to really go into the question and break it up into parts. But apart from that, it's nothing more than what you've learnt so far. We just need a little recap. So let's suppose n is a natural number, it's an integer, a whole number. Then the question for you is, can you write an expression for an even number based on the letter n? How about an odd number? And how about, can you prove that an odd number plus an odd number would always equal an even number? Let me give you a few seconds, or maybe up to about a minute on that. Feel free to write your answer in the chat window. And I can pick them up from there. Okay, if we're calling our number n, then how can we write an expression so that we can guarantee that we've got not just any number but an even number? So the simple thing is, hopefully you got it, is we multiply it by 2. So we can say n. If I times it by 2, I'm guaranteed to get an even number, because any number in the 2 times table is an even number. So I can shorten that to 2n. So 2n for the even number. What would I write if I want an odd number? Well, any even number, if I add or take away 1, then that's gonna change it from an even number to an odd number. You could add 1 or you can take away 1. The point is that odd numbers and even numbers, they come after each other in the number sequence. So once I know I've got an even number, let's say 4, then if I add 1, go across 1 or go back 1, I know I'm gonna go from the even number to an odd number. Okay, odd plus odd is even. Wondering if anyone got that. Just before I take a look, let me make a bit of space. Just to give you a big clue, an odd number on its own would be 2n minus 1. I want to prove that 2 odd numbers add to an even. Okay, no attempts yet. Maybe it's worth reminding you. Well, I can take the first odd number as 2n minus 1. I can then add another odd number. I could say 2n minus 1 again, but I'm just going to change the n to an m, because we don't know if the two numbers are the same odd number. They could be different odd numbers. So by changing the letter, I'm allowing for that. What would that equal? I need to show that it's going to be an even number, but I can't just assume it. So I need to let the algebra show me that this is going to be even. So let's simplify a little bit. 2n plus 2n minus 2. Notice that everything's got a 2 in it, which means I can factorize. Going to take that up a bit. So factorizing, that gives me n plus m minus 1. And the 2 at the front is important because that's a 2 times. And if you remember what I said before, as soon as I take a number and times it by 2, then that's an even number, because any number in the 2 times table is even. So the n plus the m minus the 1, we don't know what they are, but it's going to be a number, because they're all numbers. So a number plus another number, take away 1, it's going to be any number. still going to be a number. If I times that by 2, then guaranteed I've got an even number. Okay, if that was a little bit tough for you, you might want to go back and watch a previous video, but hopefully I'm assuming you're okay with that. And today we're going to really take that and really use it, apply it. So let's just warm you up with a simple question that it's not the maths that's going to be hard for you. In fact, none of it's going to be hard, but I just want you to try and understand the process, meaning what are the steps that you're going to break the question up into. So let's say there's 100 adults and they go to a zoo and, sorry, let's say there's 100 people. They go to a zoo, 40% of them are adults and they pay £10 a ticket, and the rest are children and they pay £6 a ticket. So the question is, how much do the 100 people end up spending at the zoo? Have a go, have a think. Should be very easy for you. Let me know once you've got the answer. Just a few more seconds. The question here is, how much do all of the people end up spending at the zoo? Okay, the maths hopefully is very easy for you, but the technique I want you to understand is that if I'm trying to work out the cost of the 100 people, I'm going to split it. If these are the 100 people, I'm going to split them into 2. I'm going to say some of these people are adults and some of these people are children. That way it makes it easier for me to do the calculation, and I can say, well, the adults first, let me deal with them. That's 40%, that's 40 adults times 10. That's £400. Then the children, well, 60% must be children, so that's 60 children, times that by 6, so that's £360. So altogether, these 100 people spend £760 at the zoo. And it's the first bit that's really the key thing. Notice how to answer this question. To make it really easy, you split the question into 2 parts, the adults, the children. And in proof, we can do a similar thing. We can, if we're dealing with numbers, then we can split the numbers into 2 parts. Instead of adults and children, we could just have odd and even, or something like that. Okay, let's get today's question ready for you. Okay, the topic's proof by exhaustion, and it means breaking it down into things that cover the whole range of possibilities. Like when I said people, I broke that down into adults and children, because adults and children, that covered everything. So that's what exhaustion means. If you're only breaking it, exhaustion. If you're only breaking it down into If you're only breaking it down into two categories, but there's actually a third category, then you're not doing the exhaustion properly. Exhaustion means you're exhausting all the possibilities and you're making sure you're not missing anything. So normally it's quite easy. It's just going to come naturally to you anyway. So this question, it's talking about proof, and we're talking about any whole number, any integer, and we're trying to prove that if I took that whole number, that integer, and I worked out x cubed plus x plus 1, the answer I will get, I'm trying to prove, is an odd number always. An odd number always. And here we're not trying to just do a couple of examples. This is proof. You have to prove that it doesn't matter how many examples you do, but for every single number in the whole universe, that this is going to be true. And you don't have time to do every single number in the universe, so you've got to come up with a clever way of proving, of showing that it's going to be true every single time. So let's split our possibilities for the x as our start number. It could be odd or it could be even. If it's not odd, it's not even, then there's no other possibility. Any number you're going to put into this equation has to be one of those two. It has to be either odd or even. So if we just now break it down into one of those two and work on, say, the odd one first. If I've got an odd number, then how do I know I've got an odd number first? Is x good enough to say that I've definitely got an odd number? Is x good enough when it comes to even to show that it's an even number? No. You've got to say the starting number I'm going to use. If I'm guaranteeing that it's going to be an odd number, I can't just use x or n or m. What do I have to use? Think back a few minutes ago. What can I use to make sure that the number I start with is definitely an odd number? Very impressed if you can type it into the chat window. Well done on the previous question. But here's the key to show that you've learned something about this topic. We need to prove that a number I put into the equation is going to come out as odd. And the first group of numbers I want to put in is an odd number. And I want to see, can you tell me the expression that I'd have to put in? I can't just put in n, there's no guarantee that n would be an odd number. How can I guarantee that the number I put in is an odd number? Fantastic. MashaAllah, praise be to God. Well done. So just having n as the number that goes in is not going to guarantee that it's going to be an odd number. If I have 2n, if I take any number and times it by 2, then that's an even number. If I take away 1 from that, then that's definitely an odd number. So I can say the number that I'm going to put in, the x, it's going to come from any number you like, times by 2, take away 1, and I know that is definitely going to be an odd number. So let's try that. Let's put in 2n minus 1 into the equation, into the function. So now I'm going to have f of x would be equal to, and I'm just going to have to make the font a little bit smaller to be able to fit it in. Hopefully it's still clear enough. So instead of writing x cubed plus x plus 1, I'm going to say the x that I'm putting in is my bracket 2n minus 1. Let's see what that looks like. I have 2n minus 1 cubed plus another 2n minus 1 plus another 1. And then you want to try and simplify that. So 2n minus 1 cubed plus 2n minus 1 plus the 1. If you want to work that out, and you can share your answer with me in a few minutes. Okay, hopefully you've had a chance just to attempt the first bit of it, and this is the bit that most people would get wrong, because 2n minus 1 cubed, you have to remember the cubed means that you're going to have the bracket 3 times. And let me just make some more space. Okay, and then you would multiply this out. You can just do the first 2 brackets, and that will hopefully be just a revision of your GCSE. So you've got 4n squared minus 4n plus 1. Once you've got those first 2 brackets done, you can then take each bit and multiply it by the 3rd bracket. Just going to write out the rest of the line. And put in the powers that I've missed. So that's 4n squared. Okay, and then just focus on, say, the 2n. If you multiply everything by 2n, and then multiply everything by minus 1. Let's go with the 2n first. So I'll have 8n cubed minus 8n squared plus 2n. And that's the 2n that I've multiplied by. So then I just need to multiply by the minus 1. Let me just put the powers in. Okay, and then continuing, instead of the 2 using the 2n, we're then using minus 1. So we then have minus 1 times the 4n squared, so that's minus 4n squared. I'll put the power in a second, plus the 4n and minus the 1. So that's all the expanding done on that triple bracket set. I'll just write the rest of the equation. Go in and put some powers in. Okay, fantastic. Just double check I haven't made a mistake. 4n squared times the 2n, 8n cubed, and keep sticking with the 2n. That's 8n. Right, I think I've just made a mistake. No, that's fine. 8n squared minus 8n squared, and then plus the 2n. That's looking good. And then using the minus 1 to times everything, minus 4n squared plus the 4n, because 2 minuses, and then minus the 1. That looks good as well. Fantastic. So then we can simplify here, because we've got minus 8n squared, and then a bit later minus 4n squared. we've got plus 2n, and then a bit later the plus 4n. So let's simplify that. The minus 8 and the minus 4, we can, minus 8 and the minus 4 can become minus 12n squared. So let's put a minus 12n squared in there. And then we've got the 2n plus the 4n, let's make that 6n. And if this is the first time you've done triple brackets for a while, then you'll get the hang of it, but you do have to go slowly initially. And then we've got the minus 1 at the end here. Now there's nothing on the outside of any of these brackets, so I can drop the brackets as long as no signs need to be changed. So that plus doesn't affect the signs of anything inside, so that can go. Here we've got nothing at the beginning of this bracket, so those two brackets can go. And then we've got minus 1, plus 1. Well, the minus 1 and the plus 1, they can disappear because that makes 0. And then what you want to notice is that that minus 1 can be brought to the end, and you can bring that just to tidy it up. And then hopefully you can see that everything apart from the minus 1 is a multiple of 2. The 8, the minus 12, the plus 6, the plus 2. It doesn't really matter whether it's a plus or a minus, but the point is it's a multiple of 2. So I can take the very same technique I did. I'm just going to cover up that 2n minus 1 just to make a bit of space. So I can just take 2 out at the front of the brackets, and I'll have 4n cubed minus 6n squared plus 3n plus n, and leave the minus 1 on at the end, and just put the powers in. And the point here is that you've got 2 times a number. Even though it's quite a complicated bracket, the point is that whatever it is, it's just going to be a number. So I've got 2 times a number, take away 1, and when I take any number and I times it by 2, that's guaranteed to be an even number. If I then take away 1, guaranteed that I've now got an odd number. So for that reason, by putting an odd number in, I'm getting an odd number out. Now let's go over. That's like saying we've done the adults, now let's go and do the children. We've done the odd numbers. We could have put an odd number into the function, or let's think about the other possibility. We could have put an even number into the function. I just need an expression for an even number. N isn't going to be sufficient, and n isn't guaranteed to be an even number. 2n is. If I put in 2n, you'll be pleased to know the expression is going to be much easier than before. See if you can work it out before me. So it's the same function, but I'm using, instead of, for the x, I'm using 2n, and I would end up with 2n cubed plus 2n plus 1. Here the cubed applies to both the 2 and the n, so you end up with 8n cubed plus 2n plus 1. You notice the 8 and the 2 are both multiples of 2, so we can factorize and bring 2 to the front. We have 4n cubed plus n plus 1. And then what's the observation? Can you write down in the chat window, if you are brave enough, what can I observe about this expression? 2 bracket 4n cubed plus n plus 1. trying to show that after putting in an even number, trying to show that I'm getting an odd integer, an odd number out. Yeah, if you did see 3n and n, that would be collected. It's a multiple of 2 plus 1, fantastic. It's a multiple of 2 plus 1. I've got 2 times, I've got a multiple of 2, I'll write exactly as you said it, plus 1, which means I've got an odd number. Okay, and because I've covered both the possibilities of the numbers that can go in, I've got an odd number coming out on both occasions, then that's the proof that any number you put in is going to give you an odd number out. Okay, if you lost any part of that, then feel free to look at the video again. Sometimes there are going to be topics, in fact a lot of times there are going to be topics when you do have to watch the video twice. First time you're going to get a bit lost, but the second time it is easier. Just to recap, the idea was really to take the 2n minus 1 as an expression for an odd number that can go in, and put it in, see what you get out, and try and rearrange it, try and simplify it so that you end up with 2 times something take away 1. We got the take away 1 at the end quite nicely. Everything's a multiple of 2 that comes before that, so 2 times any number take away 1 is going to be odd. For even numbers we're putting in 2n, and if you remember, that simplified to 2 times a number plus 1. Again, that's got to be an odd number, because any multiple of 2 is even. When you go to the next number up, that's going to be odd. Fantastic. That's something for you to go through and practice, and I'll see you next time, tomorrow's lesson at 9 p.m. Thank you for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.